memory lane of bygone years, when grandmother was a little girl spinning dreams of wonder and romance, two old men trudged the rope walk to and fro in their little back street workshop at Xenia, Ohio, spinning golden threads into endless yarns for rope and twine. Hooven and Allison, two master rope makers, were pioneers of the cordage industry in the Middle West during Civil War days. With faith in the future of industrial progress by Americans, with Americans, and for Americans. The pioneers erected this structure in 1884 to accommodate the increasing demand for quality cordage. American industry and agriculture were marching on. New methods and new processes were being developed. Scientific research and processing at an early date became a definite function in the Hooven and Allison organization and is responsible for its growth. Stretched out far below lie the mammoth mills of Xenia's leading industry, representing an investment of millions of dollars, where the great drone of hundreds of busy spinners echo as a tribute to the pioneers' ideal, quality cordage, plants covering 45 acres and manufacturing millions of pounds of products annually, a source of tax income for state and federal governments. Mills giving employment to hundreds of free American workers, enjoying the American standard of living. And speaking of workers, suppose we drop in to meet them. We present the Hooven and Allison personnel. Happy, contented employees in good environments safeguard the processing of high-quality cordage. Plans to promote the comfort and welfare of the employees have been inaugurated. Workers participate in sports and other forms of amusement. Modern homes are provided for them by the company. And life insurance protection for the workers' families. Health, too, is of prime importance. The clinic is under the constant supervision of a staff of physicians, and no expense has been spared in providing modern medical service for employees and their families. Scientific processing of cordage to Hooven and Allison standards requires scientific control. Samples of raw material are tested in the laboratory before being permitted to enter the fabrication of cordage. Yarns, strands, twine, rope, and cables are tested for yardage, strength, durability, water resistance, and insect proofing. Testing units at the point of production, checking the quality of work of the machines. Systematic methods of checking production are essential, but essential to production is wide distribution. Hooven and Allison at Kansas City. Hooven and Allison at Omaha. Hooven and Allison at Minneapolis. Scattered across America's great agricultural areas, where seas of golden grain await the call of the reaper. As the reaper passes over the field, the grain is cut and bound into sheaves with binder twine. H&A Star brand spun to give perfect service under difficult binding conditions. The use of faulty binder twine during the harvest means a direct loss to the farmer. Broken twine means broken sheaves, and broken sheaves means double, tiresome labor and a slowing up of the harvest. The arch enemy, millions of insects lurk in the harvest field, and a poor quality binder twine has little chance against the armies of insects. Star brand is thoroughly treated against attack by testing the insect resistiveness of binder twine with actual grasshoppers and crickets. Days later, the twine remains untouched. Insect-resisting treatment at no additional cost. Star twine must contain the right amount of insect-resisting fluid. In addition to being insect-resisting, it is tough, weatherproof, and made from a specially selected raw material known as sisal. From the cream of the crop in far-off Yucatan, Mexico, Africa, and Java comes sisal fiber. Sisal fiber is obtained from the leaves of a cactus-like plant similar to the century plant. It grows in semi-arid country and rocky soil. The plant matures in 5 years, after which the fiber-producing leaves are cut away. The spine at the leaf end is cut off, and the leaves bundled for removal to the cleaning machines. A machine called raspador separates the fiber from the pulp, after which it is hung on racks to dry. Later, it is packed in bales, weighing 400 pounds, for shipment. After traveling thousands of miles over land and sea, the sisal bales finally reach the Hooven and Allison fiber warehouses. These employees are expert judges of fiber quality. Samples are taken from the bales for testing and sent to the laboratory. Here, a quality check is made. The sisal begins its long journey through the mills, down through the deep canyons of pile after pile of baled fiber. It travels. Bales, bales, bale after bale, rising from floor to roof, high above our heads. Other types of fiber are also stored, awaiting fabrication into different kinds of cordage. Fiber from China, India, Africa, New Zealand, the Philippines, and Java, from the far corners of the world, off the beaten paths of civilization. The first step of the mechanical processing begins in this preparation section of the mill. Multiple combing and drawing operations are necessary in the preparation of the fiber before it is spun into binder twine. The operators examine the raw fiber more thoroughly. The bales are made up of hanks, or small bundles of fiber. Hank is composed of fine thread-like tough fibers. The fibers must be combed, cleaned, softened and straightened in machines called breakers, spreaders, drawing frames, and regulators. A simple explanation of the operation performed by these machines is a demonstration with a small hand comb. We are combing out the dirt, thin, short fibers, loosening particles of clinging woody substance and drawing out the body of fiber to greater length. This combing and drawing operation is performed more thoroughly and uniformly by these machines arranged in series. The raw sisal is fed to the first breaker for the first combing, cleaning, softening, and insect-proofing treatment. The black trough directly before the operator distributes the oil in the first stage of the processing. The treatment also increases the pliability and strength of the fiber. The rollers exert a softening pressure. Steam is passed through the fiber to assist softening and spreading of insect and weatherproofing emulsion. The endless chain of slow-moving combs apply the first gentle combing as the fiber is conveyed to faster combing, where it is drawn, straightened, softened, and cleaned. extraction of dirt or tow and short inferior fiber. Passing on through the breaker, the fiber, now known as sliver, spouts from the delivery rolls in an endless golden form. It is arranged in piles or sets for blending. Star brand binder twine is made from properly blended fibers for super strength, combining the good qualities of other fibers and blending with the sturdy sisal. The golden sliver passes through a second treatment in the second breaker. Again, the endless chains of slow and fast-moving combs, and the continuous flow of sliver. The third breaker stage in preparation, adding the insect repellent, the combing, drawing, cleaning, softening, and strengthening of sliver. The sliver is becoming more uniform and finer, and the teeth in the steel hackle combs are finer. Impurities and foreign substances are being combed out as the rapidly moving combs penetrate the smooth, soft body of fiber. The flowing sliver is gradually being drawn thinner in volume. Soft, smooth sliver at the regulator machine, but still not uniform enough. Further processing must take place to assure greater uniformity. More combing and straightening for quality binder twine. Any given length of fiber is combed hundreds of times in the various steps of preparation. Smooth, uniform sliver finally enters the finishing stage. A continuous flow of thin, finished sliver spouts from the rolls of this long battery of finishes through which thousands of miles of sliver pass each day. It has reached the end of the preparation process and is ready for testing before spinning. The delivery rolls of the finishes eject the endless flowing golden sliver. Hour after hour, samples of sliver are taken from each of the finishes for testing. Sliver is tested for yardage and uniformity. After testing, the sliver passes on to the spinning room. In this great room, hundreds of busy spinners are drawing out and spinning clean, strong, tested sliver into Star brand binder twine, spinning according to tested methods established by the Hooven and Allison Company. Trained employees supervise the spinning process and safeguard the quality of binder twine. Spinning is simply the drawing out and twisting of sliver into twine. The mechanical spinner is doing exactly the same thing. Sliver travels from container over chain guide into the nipper, where it is twisted by the rotating action of the plier, containing bobbins on which the twine is wound. Constant testing is conducted in the spinning room testing laboratories to ensure uniformity of the quality of Star brand binder twine. The twist test to determine the number of turns per foot given the twine. More or less than the standard twist means a weak twine. The yardage test. Each bobbin must contain full yardage per pound of twine. The strength test. Each ball must exceed its rated strength. After passing rigid tests, far above requirements of normal service, the bobbins are sent to the winders for balling. The finished ball is again inspected before being packed into bags or bales and trucked to the warehouse where hundreds of thousands of bales are stored, awaiting shipment prior to the harvest season. Star brand binder twine, ready to give supreme service in the fields of the nation. How commonplace is rope, and yet how varied its uses, whether it's a roping exhibition, a hoisting job, or tethering a giant liner. Rope does the work. Rope hauled the great stones used in building the pyramids in ancient Egypt. The Romans built their city with assistance of rope. The Egyptians cultivated rope fiber. Today, the finest, toughest rope fiber is manila from the Philippine Islands. It comes from the abaca plant, similar to the banana tree. The trunk of the abaca is composed of fold upon fold of leafy substance. In it, like the strings in celery, are the desirable fibers. The plant matures in 3 years and is then cut down, slit open, and the sheathing layers removed. A scraping process removes the pulp, leaving the long, silky fiber, which after being thoroughly dried in the sun, is rolled into small bundles, delivered to the government balers for grading, and packed in bales weighing 270 pounds for shipment and fabrication into rope. Rope cannot be judged by appearance. Tenacity of fiber and methods of manufacture determine rope quality. H&A Blue Heart Pure Manila Rope is fortified against rain with a specially selected fiber. All raw manila must pass through the Hooven and Allison preparation process, similar to preparing twine fiber, in a series of combing, cleaning, and drawing machines. It passes from machine to machine until it reaches the finishing section, where the rope sliver is tested. Thence the sliver is carried to the spinning room to be spun into rope yarn. Bobbins of rope yarn, after the yarn test, pass to the rope room, where blue heart manila, red heart sisal, and purple heart Java bolt rope is made or laid by the most exacting machines. Rope is made by combining and twisting 2 or more yarns into a strand, and by twisting 3 or more strands to form or lay a rope. The twist in making the rope is in the opposite direction from the twist of the strands, resulting in perfectly balanced construction. The experience of 70 years and the knowledge of our 3rd generation of rope makers, together with scientific control, is highly important at this point, because strain must be evenly distributed over the yarns in the inner strands. Otherwise, inner rupture will occur. Correct and uniform twists result in a perfect rope. Combining and twisting of 3 yarns into tying twine. Balling the tying twine. The many-end machine is one of the most interesting machines in the rope room. Yarns from many bobbins are united into banana twines, hide cord, and lath yarn. This machine is sometimes called the Flying Dutchman because it reminds one of a merry-go-round. The twine in the form of a soft rope is drawn from a long tube in the rear of the machine and wound onto a coiler. This put-up enables the buyer to cut twine in equal lengths with one stroke of the knife. In the first step of rope making, 2 or more yarns are formed into strands. Filled bobbins then pass to the rope machine or layer. 3 or 4 bobbins of strands are placed in these layers and twisted or laid into rope. Red heart rope, 1/4 inch to 1/2 inch in diameter for tents, awnings, farm work, and general purposes, is made on this battery of machines. A series of upright combination machines. The 2 operations of forming the strands and laying the blue heart manila rope are done within the same machine. "36 bobbins of yarn are placed in the inner creel or frame, which revolves in the opposite direction from the pliers forming the strands. The strands are united and twisted in the tube, and the finished 3/4 inch rope rises from the top. The larger the rope, the larger the strand. A strand-forming machine twisting strands for hay carrier rope. Yarn passes through the register plate guide to be twisted into strands in the stranding tube. The bobbins containing the strands are transferred to the rope-laying machine to be twisted in the die in the forming head of the machine and drawn off finished rope. die in the forming head is made of hardened steel and acts as a guide and mold for accurate twisting of the strands into rope. Perfect dies contribute their part to the making of quality rope. Strands are being combined and twisted into 1-inch rope on this horizontal laying machine. Notice how the strands meet at the die head and are drawn off onto a coiler at the end of the layer. Whirling strands enter the head containing the smooth steel die that unites them into solid, tough manila rope. The bobbins containing the large strands are placed in position on the transmission rope laying machine. The heavy strands are drawn into the die head, where they are combined into 4-strand transmission rope. In addition to combining the strand at the head, a lubricated core is inserted at this point. The lubricated core reduces the effect of destructive internal friction. Correct laying of the strands at the head is highly important. And again, the die mounted in the center of the head ensures a perfect twist. Large rope of 1 inch or more in diameter requires large strands formed from multiple yarns. Here is the strand forming machine which builds the strands for bull rope, transmission rope, marine rope, and large rope for other uses. Yarns from many bobbins unite at the guide or register plate and are formed into strands in the stranding tube. After the bobbins are placed in position in the huge upright layer, the machine whirls the heavy strands to the overhead forming tube. As the strands rise to be combined into strong, heavy bull rope, they meet the blue thread, which becomes the blue heart of the rope, a mark of distinction in cordage. Forming head die from which the finished rope emerges. From the forming head, the finished rope descends and is wound upon the take-up reel. Bull rope is used on drill rigging in the oil fields. The giant cable laying machine, which rises to a height of more than 2 stories and weighs tons. 3 1-inch ropes are laid into 2-inch cable. Cable rope is used for drilling oil, gas, and water wells and for drilling blast holes in quarries. Cable rope is also formed by means of a die placed in the forming head. The testing laboratory, the proving ground of Hooven analysis, where actual stock samples of rope pass rigid tests. The water test, an untreated common variety. Untreated rope becomes waterlogged and sinks. Waterlogged rope becomes soft, flabby, and useless. Blue Heart resists water and floats on the surface indefinitely. Here, Blue Heart is being subjected to a most destructive, wearing, and straining test. A continuous grind with a heavy load, hour after hour, days of testing, and no sign of rupture or wear. The third degree, testing its maximum braking strength. 1/2 inch. 2,800 pounds. 1 1/4 inches. 14,000 pounds. 2 inches. 32,000 pounds, dramatic proof of super strength. The trademark of strength and durability. The thread in the center. Blue Heart, Red Heart, and Purple Heart rope. Hundreds of thousands of miles of rope have been shipped from this warehouse, enough to reach many times between America and the Far East. From the Far East in India comes the jute fiber, the raw material for commercial twines. India, the land of the Taj Mahal, a land of strange people and quaint customs. The family laundry is still done on the banks of the sacred Ganges. The bullock still furnishes the principal means of transportation. From this faraway land to Xenia, Ohio, is brought jute fiber. Raw jute is trucked from the jute warehouse to the bale breaker. The first step in preparation is the softening and steaming operation before it is permitted to enter subsequent stages of combing. The first carding machine, in which fine steel rotary combs extract the tow or dirt and short fibers. The delivery end of the first carding machine, from which smooth, soft jute sliver flows. The feed and delivery end of the second carding machine, in which the second combing is done. From the carding machine to the first drawing frame, where the sliver is drawn out to longer and finer body. Repeating the process on the second drawing frame. Ready for light twisting into rove or the first coarse yarn. The rove machine applies the first light twists. Bobbins containing the first spinning or rove are removed or doffed and conveyed to the fine spinner. the fine spinners where rove is drawn out and spun into finer yarn. The rove yarn passes down, is drawn out, twisted or spun, and wound on receiving bobbins. When these bobbins are filled with fine spun yarn, the machine automatically is doffed and bobbins removed. Automatic doffing or removing of these many bobbins is completed in one operation. The yarn from the fine spinners is sent to the twisters or formers, where it is united with other yarns to make 2 or more ply twines. If the twine is sold unfinished or unpolished, it is wound onto reels or into balls ready for use. If the twine is to be finished, it passes to the polishing machine. The twine passes from the bobbin through a size bar, where it is coated with a polishing material. Excess sizing is removed by brushing rolls before passing over large steam-heated cylinders which evaporate excess moisture. While passing over the steam-heated cylinders, it contacts the multiple rolls which polish the twine. Finished twine is wound on bobbins. The bobbins are conveyed to the balling machine, where the finished twine is balled. Or wound on reels. Clothesline in the making. After polishing, it is hanked. Then labeled, ready for the housewife. The twine tube winder. Constant testing based on standards far exceeding ordinary requirements. The twist test. The strength test. The stain test. Twine must not soil the package. the oakum mills, where Mayflower marine and plumber's oakum is made from fine jute and hemp. Mayflower brand oakum. The parade of products ready to serve the nation.